My name is Suparnojit Ghosh, and welcome to Decoding Physics, my beautiful channel. Uh, in this video, I am introducing my new playlist which I'll be posting on YouTube about my learnings from my class 12th chapter electromagnetism on a specific device called cyclotron and synchrotron. Although I didn't study the synchrotron part in my curriculum, but I was interested in that and kind of studied it. And I proposed some new idea to myself. Obviously, I am still learning, and I would be posting these things on YouTube in my way. So let's learn together. So. Uh, let's go what we are covering in this series. Let's look at that. Uh, what are we going in to cover in this video? What is a cyclotron? What is a cyclotron? Uh, it's not a sci-fi out of the box, out of the universe thing. It's a kind of simple device if we look at the physics, but to make it work, we have to really do some insane engineering because accelerating a particle to nearly the speed of light, it's not a cakewalk, obviously. So uh, let's not talk rubbish. So cyclotron is a device which uses the properties of electric field and magnetic field. I mean the Lorentz force, to be particular, to accelerate a charged particle, say it's a proton, electron, beta particle, or any other charged particle, to near the light speed, which is 3 into 10 to the power 8 meter per second. And there are some flaws in this machine, but we will talk about that in later part of this series. Why are we talking about cyclotrons? We have synchrotrons to talk about. We have synchrotrons to do the physics stuffs, do the experiments and all that. So here you can see the meme. Please don't get hurt. I'll have to study in a kind of funny way. Can you deliver pizza by rocket ships? Now I have hope you get my joke. So to do bigger things, we have to start from the grassroots level, right? So that's all. And what's the physics behind it? The main thing about which it works is that it uses simply Lorentz force to accelerate the charged particle. Here it's written in a good way. In a nutshell, we can see F equal to Q into E vector plus V vector cross B vector. What's these? Here F is obviously the force acting on the charged particle. Q is the charge on that particle. And we assume that it has a mass m, small m. And E vector is the electric field vector. This is the E vector, electric field. V vector is the velocity. And P vector is the magnetic field. So if by this formula, we can simply get the force vector which will be acting on that particle in presence of electric field and magnetic field, provided it has some velocity, or it may not have some velocity. It may have zero velocity, but if we accelerate it, it will gain it. What is omega? Omega is the angular frequency of the revolution around the T's of the cyclotron. What is a D? We will talk about it in the later part of the series. Obviously, this is an introduction video, and electric field is a sinusoidal function. Oh, what is this? sinusoidal function is a function that repeats itself after a fixed time period, like sine wave, cosine wave. Yes, these and many functions which can be built from these two functions, and there are other waves also, square wave, triangular waves. But we prefer to use sine wave and cosine waves in this part of experiment. We will talk why we use that. Okay, so uh, this is the introduction video for my series, and I hope that all the viewers who are watching this video will understand the physics from its grassroots level, because physics is such a beautiful subject we can work with. And always learn the principles, not the formulas, right? It's said by Richard Feynman, my favorite scientist, theoretical physicist. Thanks a lot.